Assalamu alaikum everyone. My name is Mohammad Arslan and I am a student of MPhil Data Science second semester from the Islamic University of Bahawalpur. Today I am here to present my project, an end-to-end data engineering solution using real Uber ride data. This project is not just academic, it's a practical. It covers everything from data ingestion to visualization using real tools that are used by data engineers in the industry. So let's begin this data-driven journey together. Here is what we will cover in this presentation. Firstly, we will cover introduction and motivation, why this project matters, problem statement, what issues we solved, dataset overview, what kind of data we used in this project, then state of the art. In the state of the art, we see that what tools and technologies we applied in this project. Then methodology. In the methodology, to check that how to project was executed step by step. In the second last, results and discussion, what we achieved and challenges we faced. In the last one, future work and conclusion. Let's start by understanding the purpose behind this project. In introduction, the project focused on designing a modern end-to-end data engineering pipeline using real-world Uber ride data. Companies like Uber generate massive amounts of ride data every day. The goal of this project was to show how a data engineer can build complete system using the following workflow. Firstly, we ingest our data, then transform, then structure it into a model, creating modeling, then finally data visualization. In the next, we see that what we used tools and technologies in this project, like Python for data pre-processing and transformation, Google Cloud Storage and BigQuery for storage and processing, Mage for pipeline orchestration, Looker Studio for intuitive data visualization. This project gives a real world view of how data engineering adds a value to business. In the next, motivation. In motivation, we see that urban mobility is evolving. Companies like Uber generate massive ride data daily. Like platforms like Uber collect huge amounts of data every day. By studying this data, we can understand user behavior, improve services, plan better routes, then predict its demand. This project is to provide a real-world demonstration of how data engineers manage the complete data lifecycle from ingestion to reporting. It means the motivation behind this project is to demonstrate how real data is handled, processed, and turned into value by data engineers. In the next, problem statement. In problem statement, we have operational bottlenecks. What is operational bottlenecks? We also say that operational bottlenecks, that what key challenges we faced during our project. Firstly, we converting unstructured CSV data into optimized analytical format. That the data was in CSV format, unstructured and messy. Then design a scalable data model that supports various analytical queries. It means we had to design a star schema with proper dimension tables. Then creating dimension tables that enable multifaceted analysis of trip data. Like we build a fact table to store transactional data. Then the second last operational bottleneck is establishing a robust pipeline for ongoing data processing. It is set up an automated ETL pipeline. The last one, developing visualization that reveal key insights from the data. We can say that we create interactive dashboard for business users. This project is a complete data lifecycle demonstration from raw to refined. In the Uber dataset overview, you can see that Here is our CSV format data structure data what we used in our project. It had 100,000 rows and 20 columns or features. But from that datasets, we extract its key features from Uber datasets like pickup and drop off timestamps, passenger count, latitudes and longitude, fare, trip, taxis, payment type and rate code. This rich data, it allows us to perform analysis on time, location, cost and customer behavior. It's mean all in one place. In the next, we see that state of the art. State of the art, we use modern cloud-based tech stack. It means we used Google Cloud Platform, Mage, BigQuery, Looker Studio. What is Google Cloud Platform? Google Cloud Platform is to store and process the data. It is scalable, reliable infrastructure for big data processing. We also use its alternative AWS and Azure. And why GCP is good? Because it's cost effective with strong ML and data tool integration. Then we see that Mage easy to use pipeline orchestration. It means it automate our ETL pipeline. Now we see that what is orchestration tools. Orchestration tools, it acts like a conductor in an orchestra, ensuring that all parts of systems like applications, servers, containers or services work together smoothly and in the correct order. We also use its alternative Apache Airflow Prefect LUG. Why Mage is good? Because it automates and manages data workflow efficiently and easily. Then we see that BigQuery. BigQuery is a serverless scalable data warehouse for fast analytics. It means BigQuery is used to run fast SQL queries on large datasets. Its alternative is Amazon Redshift, Snowflake, Azure Synapse Analytics. And the BigQuery is good because it handles complex queries on large datasets with ease. And the final stack is Looker Studio. Interactive dashboard for clear data visualization. It creates interactive dashboard for clear data visualization. We also use to create a dashboard that is Tableau, Power BI, Qlik Sense. But here we use because Looker Studio is seamless integration with GCP and low cost reporting. These tools are scalable, cost effective and perfect for enterprise level data projects. These are the tools architecture. This is tools architecture. Firstly, create a cloud storage, then create VM instance, install Mage library and connect with BigQuery, and finally create dashboard using Looker Studio. After it, in methodology, let me explain our technical workflow, how we use what methodology. Firstly, we use data ingestion, load the dataset from GCS using Python. Then data preprocessing, like remove duplicates, formatted timestamps and added unique trip IDs. And the next step is dimensional modeling. What is dimensional modeling? Dimensional modeling created dimension tables for time, distance, rate code, payment type, etc. It means we create a child tables from the main datasets to integrate with parent table. Here is its structure. what we create dimension tables. Here is 7 dimension tables, that is also called child table, and one is parent table. We assign its name fact table. Fact table linked all dimension keys with main trip data. In the next step, pipeline orchestration. Pipeline orchestration automated transformations using Mage on Google Compute Engine. In it, we load the datasets in Mage ETL pipeline, then process, and after it we export the dataset to data warehouse. Here is our data warehouse. Data warehouse is BigQuery. Export and load clean data from the Mage pipeline into BigQuery for further analysis using SQL. Then finally analysis dataset connect with our Looker Studio dashboard, which they build a dynamic dashboard using Looker Studio. Every step was part of professional grade data pipeline. Now we talk about its results, what we find and what we achieve. Here's what we achieved in the final stage. We create a dashboard that shows total revenue, trip distance, fare breakdown, passenger count distribution by type, filter for payment type, vendor and rate code, geolocation, map showing popular pickup zones. Here is the glimpse of the dashboard. Firstly, dashboard show total revenue, trip distance, fare breakdown and record count etc. Then filters vendor ID, payment type, rate code and trip distance. When we filtered, then automatically change its figure and automatically change its payment type analysis graphs. It's a bar graph. Here it shows that which location use what type of payment method. Then here we show that which payment method mostly used and minimum used and average amount used. Finally, geolocation map showing popular pickup zones. These dashboards convert raw data into real-time actionable insights for business. In discussion, we also faced real challenges like data quality issues, schema design decisions, cloud resource management, ETL pipeline robustness. In the data quality issues, we face challenges like handling null values, duplicate records, inconsistencies format in the raw data, missing data etc. While in the schema design decisions, merging issues when joining multiple tables, like we join our dimension tables with our main fact table for improved query performance and simplified analysis. Then cloud resource management, because we optimize compute and storage resources for cost-effective processing. Then ETL pipeline robustness, ensuring the transformation process handle edge cases and maintain data integrity. Challenges included handling date-time convenience and ensuring data integrity during manage. We can say that date-time convenience required precision, but we resolved these using best practices in ETL data validation and testing. This gave me hands-on experience with real platform faced by data engineers. In future work, how we improve this project? We improve this project using real-time data processing, machine learning integration, advanced geospatial analysis, advanced data lake architecture, automated monitoring. If we talk about real-time data processing, add real-time data integration using Kafka or PubSub. Then machine learning integration, use machine learning models for demand predictions. Then advanced geospatial analysis, add geospatial clustering to find high demand areas. And the final, second last, data lake architecture, implement more scalable data lake approach for storing raw and processed data. It means use data lake to manage raw and semi-processed data. Finally, automated monitoring, it creating data quality checks and pipeline monitoring tools. Build monitoring tools to track pipeline health and performance. These upgrades will make this pipeline even more powerful and intelligent. In conclusion, we finally concluded that built a complete end-to-end data engineering pipeline, transformed raw Uber data into structured analytical format, then used real tools like Python, GCP, BigQuery and Looker Studio, open source tools, and the second last, creative interactive dashboard to support real business insights. Finally, it demonstrates real world value of data engineering in decision making. You can explore more at the links below. This link is a video tutorial of this project. Here you find out datasets, and this GitHub repository has all sources code, this project code. Thank you so much. Special thanks to Dr. Akmal Khan, who is my supervisor, for his kind guidance. Thank you so much.